So I'd like to talk a bit about multiplication, or what's known as foiling or factoring, depending on which direction you're going. So we'll work with, 5 times 7. Okay. So you might know that 5 times 7 is 35. But we're going to rewrite this. We're going to forget what it is. And we're going to do this sort of step by step. See, 5 is equal to 2 plus 3. And 7 is equal to 3 plus 4. So now this is our problem. We're trying to figure out what 5 times 7 is. Now, we want to break this down even further, and so we're going to have it written down like so. See, I sort of split the 2 plus 3. Now, it's not completely obvious that you're allowed to do this in general, but it's believable, and it turns out that you can. You could do this type of thing. You could split the 2 plus 3 to make it 2 times plus 3 times, and it doesn't really matter what's in the parentheses. But we're going to see that in this example it works out. But even this isn't broken down as much as it could be. So I'm gonna just break down half of it. 2 times 3 plus 2 times 4 plus 3 times 3 plus 4. So I've just broken down this part the same way I did this step. That's going from this step to this step. I've just broken down 2 times 3 plus 4 into 2 times 3 plus 2 times 4. And then I'm going to do the same thing for the 3 times 3 plus 4. I'm going to break that down, and then I'll multiply all the individual terms, which I'll have 4 of, and I'll add them together to see what I get. So this is equal to 2 times 3 plus 2 times 4 plus 3 times 3 plus 3 times 4, which is equal to, well, 2 times 3 is 6, plus 2 times 4 is 8, plus 3 times 3 is 9, plus 3 times 4 is 12. So that's what I have so far. And it's just like a way to break down the multiplication. In fact, if you were given this step, you could go backwards up to here by sort of pairing the numbers appropriately. I mean, this is just one example. So I'm going to actually rewrite this before I add it to make the addition even simpler. I'm going to write 8 plus 12 plus 9 plus 6. To me, this makes more sense. To me, this seems like an easier way to do things. Because I feel like it's more obvious that that's 20 plus 15, which is 35, which is what we wanted in the first place. So at least this is, the general concept of factoring, and I mean, there's also the backwards process of this. It's like how multiplication and addition relate to each other. And okay, so this example I did with numbers that I knew I knew which numbers I was working with. I mean, I had 2, 3, and 4, and we're familiar with those numbers. But like, if we didn't know what the numbers were, or if it wasn't numbers, if you say 4 tables in math language, that's really 4 times tables. I just said times tables. Or like 3 tables is like multiplication in a sense. And so if you have 4 tables plus 3 tables, it's 4 plus 3 times tables, which is 7 tables. And so this doesn't only work for numbers, it works for objects, and then for numbers that are unknown, or just in general. That's how our familiar addition and multiplication relate to each other. Yeah.